small mass m is attached to a massless string whose other end is fixed at p. Okay, a small mass m is attached to a massless string whose other end is fixed at p, as shown in the figure. The mass is undergoing circular motion in the xy plane with center at O and constant angular speed omega. If the angular momentum of the system calculated about O and P are denoted by LO bar and LP bar respectively, then LO bar and LP bar do not vary with time. LO bar varies while LP remains constant. LO remains constant while LP varies with time. Both vary with time. Okay. Now if you don't know, this particular assembly is also called as conical pendulum. Okay, this whole assembly is also called as conical pendulum. And its time period is given by 2 pi root L cos theta by G, where theta is the semi-vertical angle of the cone. Okay, where theta is the semi-vertical angle of the cone. Okay, but that is not of any interest to us. We would like to determine the variation of angular momentum of this body M about O and about P with time. Okay, fine. Recall the definition. What is the definition of angular momentum? It is R bar across P bar. Do you agree to this? Well, that's definition. Okay. Now, suppose R bar is R. Okay, let's call the radius a smaller. R cos theta I cap plus R sin theta j cap. Okay, what will be V bar then? Negative R sin theta omega I cap plus R cos theta omega j cap. Do you follow this?
Yes, sir.
This is with respect to origin. Huh? This is with respect to origin, assuming that to be the xy plane. Okay. So what will be angular momentum about O? R bar cross P bar. Ijk. We can take R common because that is radius. Cos theta, sin theta, 0, and V will be, let us take R omega common, negative sin theta cos theta 0. Now look, theta is changing with time, we know that, but is this determinant's value, or well, that change with time 0I minus 0j plus what? Cos squared theta minus sin squared theta. That's not going to change that. That will be plus k cap. Okay. Well, I forgot to multiply this by mass, but that is not going to play any role. So that is constant in both magnitude and direction. So it doesn't vary with time. Is that clear? Remains constant both in magnitude and in direction. And we perhaps knew this result. In UCM, the angular momentum is always constant, both in magnitude and direction. And that's constant angular speed means what? That's UCM. Constant angular speed means it is uniform circular motion. Okay. Now let us think about finding its angular momentum about point P. Okay, finding its angular momentum about point P. Okay, now how can we find it? Look, for LP bar, okay, for LP bar, is it not, okay, let's borrow this figure, I'll paste it there. Okay, I'll paste it here, a bit enlarged, yeah, that's better. Okay, LP bar is, okay, let me call this point as M now. So do you agree that it is PM bar cross V bar? Sorry, MV bar? Yes?
Yes, sir.
Okay. Now can I write PM bar as PO bar plus OM bar. By triangle law of vector addition. Yes. This is PO bar. This is OM bar, and that is PM bar by triangle law. Okay. That is PO bar cross or PO bar cross MV bar plus OM bar cross MV bar. But what is OM bar cross MV bar? That is R bar. Sorry, that is LO bar. Because what is OM bar? It is R bar. Right? OM bar is R bar. Well, I'm writing this after we have named it M. Okay, so that is constant. Okay, that is constant. Now let us assume that this length is, let's say, small l. This length is small l. Okay, so what will be PO bar then? Can I not say that PO bar is negative LK cap? Yes, negative LK cap. So now let's find out the cross product of PO bar with negative LK cap. Sorry. PO bar and MV bar. Negative LK cap cross MV bar. Okay, yes, let's find it out. 0, 0, negative L. Okay, and what is MV bar? M will come outside. Omega and R will also come outside. And negative sine theta and cos theta will remain inside. Is that clear? So it will be I cap into L cos theta, I cap into L cos theta minus J cap into what? Minus J cap into L sin theta plus 0 into K cap. Yes, okay, 0 into K cap. So we basically find that this varies with theta. Okay, as theta varies, this quantity varies, therefore LP bar also varies. Okay, well, let me add it here. Therefore, as theta varies with time, that's important, right? Because all our efforts are to prove that. As theta varies with t, above cross product varies in direction. Magnitude wise, it is still same. Okay, it varies in direction. Therefore, LP bar also varies in direction. Okay, can you tell me what will be the magnitude? Magnitude of LP bar will be what? Okay, can you tell me that? Well, I'm sure it's constant. Look, it will be L squared for these two, L squared cos squared theta plus L squared sin squared theta, and the K component is MR squared omega. Okay. Oh, okay, sorry, I have not written MR omega there. Yeah, that's my bad. Wait. Let's complete it. Although we have got the answer, let us just obtain the final expression. Okay, so is that the same MR omega? Yeah, okay. So L squared plus R squared outside the bracket MR omega. Okay, understood? The magnitude? Okay, yes. But the direction varies. So which option is right? LO remains constant, but LP varies with time.